Okay guys, welcome to your tutorial on simplifying algebraic expressions. Today we're going to move on. Last lesson we had a look at writing basic algebraic expressions. Today we are going to look at simplifying them. So we're not solving anything anymore, we're simply simplifying. So let's get started. Okay, this is the key bit of information, guys, that you need to understand. Collecting like terms. It's probably the most important thing that you will learn, okay, today. Connecting like terms is about finding pronumerals that are the same, okay, the same. And when we connect like terms, we group these same pronumerals, okay? We group these same pronumerals. As well as just the pronumerals, you can have actual numbers that are by themselves. That's another kind of like term. So let's have a look at what we've got, collecting like terms. Let's look at this one here, okay? Again, we're going to simplify these expressions by collecting the like terms. So we're going to simplify. Oh, sorry, I spelled that wrong. Simplify. We're going to simply simplify this expression by collecting like terms. Now, when I look at this, I've got 3x plus 2y plus 4x plus 7y. I've got a 3x and I've got a 4x. They are like terms because they contain the same pronumeral factor of x. It's like saying I have 3 apples and 4 apples. Then I've got another one, okay? I've got another pronumeral factor in here. I've got 2y and 7y, okay? Why are they say like terms? Because they have the same pronumeral factor. So I've got 3x plus 2y plus 4x plus 7y. I can group these. However, I can only group like terms, okay? So I can group this guy here and this guy here, and I can group this guy here and this guy here, okay? The sign, in terms of if it's a positive or negative, is determined by the sign directly in front of it. So that positive belongs to the 2y, that positive belongs to the 4x, and that positive belongs to the 7y. So 3x plus 4x is 7x, plus 2y plus 7y is 9y. It's as simple as that. Okay, guys? It's really not too tricky. Okay? 7x plus 9y. Collected my like terms and put them together. Now, I can't put together 7 apples and 9 oranges, or 7x and 9y. So that's as simple as I can get when I'm collecting my like terms. Let's look at another example. Okay. What about this one? Ooh, it's not expanding. There we go. Simplify. 3x plus 4 subtract 2x. Like terms here. The 3x and the 2x. Okay? Plus 4. 3x subtract 2x. Now I know it's a subtract because this sign here belongs to whatever value comes directly after it. Okay? So 3x subtract 2x is 1x. A reminder, I do not write the phrase 1x. Okay? 1x is simply written as x. So it becomes x. Now my 4 I can't group because I don't have a similar like term. So it becomes x plus 4. I am grouping the like terms, okay? So I've grouped my purples. 3x subtract 2x is x plus 4. I can't group the 4 because it's not a like term. Another example. Okay, let's have a look at another example here. It's a bit more of a tricky one. Okay. Let's have a look. I've got 8ab squared, subtract 9ab, subtract 8ab squared, plus 3ba. Okay? Let's have a look at my like terms. Okay, ab squared. is a like term, okay? Because I'm doing addition and subtraction, okay? I've got AB squared as a like term there and AB squared as a like term there. I've got 8 of them in the first instance, okay? And then I've got 9AB and 3BA. Listen to this point now, okay? 9AB, okay, and 3BA are like terms. AB is the same as BA. It doesn't matter what order they're written in, okay? Doesn't matter what order they're written in, okay? They are the same thing. Commonly, however, you will find that they are written in alphabetical order. So it'll be written AB. But AB and BA, it's like saying A multiplied by B is the same as B multiplied by A. Okay? It's pretty straightforward. So, what have we got? 8AB subtract AB squared. 8AB subtract AB squared becomes 7AB squared. Okay? Negative 9AB plus 3BA, or AB, whichever way you want to say it, becomes 6AB. I've only grouped my like terms, so terms that are similar, okay? When I am adding or subtracting or trying to simplify like terms, I always have a look at the sign in front. That is the sign that owns the value, okay? So here it wasn't 9 plus 3, it's negative 9 plus 3, or negative 9AB plus 3AB, or BA. Doesn't matter what order they're in. Okay, today we're going to look first off at multiplying algebraic terms. So my set question says simplify the following. Sorry, they're actually two different questions. I'll pop this little guy up here for the moment. We'll ignore him. Simplify the following. 3 multiplied by 2b. Okay? Simplify 3 multiplied by 2b. Now, another way of writing 3 multiplied by 2b is 3 multiplied by 2 multiplied by b. That's separating my term into individual units. And 3 multiplied by 2 is 6. Multiplied by b becomes 6b. Because remember yesterday we were having that conversation that multiplication, or if you're multiplying a number by a pronumeral, you simply write it as the number and the pronumeral with no gap in the between. That means multiplication. Again, this should be a revision for you guys. So if I was to simplify 3 multiplied by 2b, I'd simply write it as 6b. Okay? Excellent. Let's move on. My next example that I have here is this one. Okay. So, I can't expand it. There we go. Simplify the following. Negative 2a multiplied by 3ab. Another way of saying that is negative 2 multiplied by a multiplied by 3 multiplied by a multiplied by b. Okay, right, what have I got here? Okay, so negative 2 multiplied by 3. Okay, negative 2 multiplied by 3 becomes negative 6. I group my like terms, okay, like we just learned. I group my like terms. So I can't group the b's and the a's, but I can express them separately. So a multiplied by a becomes a squared, okay, and there's one b, so I write b in there. How I've done that is that term, these terms, and the b. The b goes there, the a's go there, the 3 and the negative 2 becomes negative 6, okay? That's how I simplify. Negative 2a multiplied by 3ab becomes negative 6a squared b. That's simply simplifying my terms. Okay, now let's have a look at dividing, so doing the opposite operator. I have 12a squared b divided by 3ab. Now, this is really particular, guys, okay? We no longer write division like this, okay? When we're writing, we always write it as a fraction. So it becomes 12 a squared b divided by 3ab. Just like when we had normal fractions, we can actually cancel this fraction. So 12 and 3, let's deal with those terms first, those like terms, because they're the numbers. Okay, 12 and 3, highest common factor between 12 and 3. 3. 3 goes into 3 once and into 12 4 times. Okay, a squared and a. A squared is the same as saying a multiplied by a. So a squared divided by a, sorry again, a squared divided by a leaves just one a on the top, okay, because a squared divided by a, that a cancels out and I can get rid of the square. Now b, I've got a b on the top and a b on the bottom. B divided by b cancels each other out. So what am I left with? I'm left with 4a on 1. Oh, that's easy. That just becomes 4a. Okay? Because all I have left, got rid of that. That's become 4. I've got rid of the b. It's just 4a on 1, which becomes 4a. It's as simple as that, guys. It's pretty straightforward. Okay, let's have a look at another example. So this one, simplify the following. This has been given already as a fraction, which makes it super helpful. So I'm just going to write it out again. 6ab on 18b. Again, I am looking for the highest common factor in order to simplify my first like terms, which are these guys. 6 and 18. Okay, highest common factor is 6. 6 goes into 6 once and into 18 3 times. My b's cancel each other out. So I'm left with 1a on 3. If I were to write that out, it'd come out as 1a on 3. Instead of writing 1a, I actually just showed that as a on 3. And it's as simple as that, guys. That's how I simplify divisional algebraic terms.